Hello, and thank you for attending another Ekahau short how-to video by Advanced Network Devices. This is Mike Kazemian. Today we will be discussing the 3D advanced features of the Ekahau AI Pro Online platform. In this demonstration, we will see how easy it is to create a realistic 3D model with the new elements or tools that are at our disposal for designing a 3D model. In order to do that, we simply go to AI Pro Online. We select the floor plan. We name that floor plan 3D design, 2 stories, 2 floors, and we start from scratch. We pick up our floor plan. We have selected a simple floor plan in order to show the differences between how we can use various tools that we have at our disposal. We will not modify anything here. We go to the next stage. This is for the scaling. We know exactly the scale to be roughly from here to here, 21 meters, which is correct. And if we measure that, we can see exactly that is about 21 meters right here. And we finish. And we will add another floor just to show you how different functions or elements can be used in this design process. And we will not change anything. Next step is to do the floor alignment. As the floors are exactly the same, the alignment process should not take very long. And this stage is mandatory for any design process to ensure that everything will align. Common points of alignment are stairs or columns that we might have. And we can see it is completed. We finish. We don't want to add any floors. And we have our 2 floors we can see on top of each other, but they are not yet 3D. Now, here we can see that we have some air ducts at our disposal, and then that we need to modify and create a 3D element for, and then we have the stairs. Of course, we have the walls and whatnot. The height between the 2 floors is 2.5 meters or 250 centimeters. We have 10 stairs here. So we know the exact height, and we know the length. We know from here to here is about 3 meters. So we know we have 10 stairs. So we know also the dimensions of these stairs as well. Now let's take a look at the tools that we have at our disposal. Before we had the wall element, we had the attenuation object, but we did not have the elevated surfaces. And the floor opening also was there, but this element or this function was not there at our disposal. Now, we have to strategize and select the right element to utilize in order to be able to have the proper 3D modeling design. In this case, I'm going to use the attenuation object for the air ducts that we have available here. These are the inlets for the air ducts. And then for the stairs, we are going to use the elevated surfaces. Now, we can first start with the air duct. So we can go here, and we can see air duct is not here. We assume that we know the attenuation of the air duct. We add a new material. We call it air duct. We assume attenuation is 4 dB. We select the color for it. I'm going to select the bright color so we can discern. And we can see it says the height of the air duct. We assume it's 0.5 meter. And we can say distance from the floor is 2 meters. So it's 2 meters that the base of the air duct starts, and it goes to 2.5 meters. We add. Now we have the air duct feature built in. Now in order to do that, we make sure that we have the right attenuation or right function, which is the attenuation object tool, and we have the air duct. So we go and we create our air duct. We can see it's very straightforward and very easy. And we will be finished shortly. Hopefully we haven't missed any elements of the air duct. We can do small adjustments here to make sure the thicknesses are correct and everything. So let's take a look at it in 3D, and we can see, lo and behold, we have the air duct. Now we can also take a copy of this and move it to the other floor. So we can say control copy, and then we can go to the other floor and we say control V, and then we have the second floor air duct as well. We might want to do a little bit of adjustment to make sure everything fits in place. We can see now we have the second floor, and this is the floor on top of it. So we can see right here that the air ducts for the other floor is created. Now let's go and create the floors so we can see what's going on. This is the top floor, and this is the floor below it. Now on the top floor, we can go to the elevation surface, and we can select the attenuation value. We can select the thickness, and here we know that it's 0.25, and distance from the floor, top floor, is 0, so it's minus 0.25 centimeters. So we can zoom in a little bit so we have a pretty accurate representation of the floors. So we can go here and we can select the tool, and we can see we have created this first step going down from top floor to bottom floor. Now we can go and we can say minus 0.25 for the second step, so we can see distance from the top of here to the next stair is minus half a meter. So we select here and we repeat this process. So now we have another 0.75. So we say half a meter. And then here we select for the next step. These four constitute 1 meter. Then we select minus 1. I hope it's very clear exactly what we are doing here. Next is 1.5. Next is 1.75. next one is 2. And the next one is 2.25. And we can see we have perfect 2.5 meter between the floors. So now let's take a look at see exactly how everything looks in 3D. We can see that we have created the 3D image. If we want to add now walls, we can do that as well, just to see exactly how things are. This is the top floor. So I'm gonna create a wall here just for us to see what will happen. I'm gonna select drywall. We're gonna go from here. I'm gonna zoom in a little bit just to, of course we have wall detection as well, but I'm not gonna take time for that. Okay, and then we can go from here to here, and we can see now the 3D image of the wall created. We can now copy this to the other floor. We can go other floor and we can say paste, and we put it right exactly where that location is. Now when we look at it in 3D, we can see that we have all the necessary elements exactly on top of each other. We can also here take the bathtub and also do the same thing for it. We can put water inside here using the same technique and methodology. Now if we want to, if we are done with this, then we can go and we can try to put an access point just for the argument's sake, see how it is. We don't want to place all, we just want to put one. So we just put one here, and we can see that AP is placed and the signal is propagating on this floor. We can also see this in 3D view. You can see that on the stairs there is signal propagation. If we go now to the floating signal strength, then we can now see how the signal changes and propagates as we are changing the situation. We can of course add other elements. We can turn on the wall detection to detect all the walls here, but generally you can see now how we can strategize to use the two tools that we have available, attenuation object and elevated surfaces. For example, you can use the elevated surfaces for the bathtub here, for the toilets, for the wash basin, for the stairs, for any columns that you have. Stadiums, the seating can be used for elevated surfaces, and then you can use the attenuation object for other elements that are within the environment, like seats, chairs, store racks, warehouse racks, things like that. We can use that. And then we use the wall object or function for attenuation surfaces that have a limited thickness, but they have a length, and then they have a height, like windows, doors, and so forth. This shows you how we can now use this feature to be able to do a realistic 3D model of the environment, so we can have a proper Wi-Fi design and final optimization of the project that we have at hand. This concludes our short presentation of 3D advanced features of AI Pro Online within the Ekahau Cloud platform. I thank you for attending this short how-to video. If you're interested in similar short how-to video, please do subscribe to our channel. on YouTube.